What a nice view. We have a lava fall and a few waterfalls and some trees here. And we also have a light. 2 lights from Electrical Age. This has been the video you have been waiting for. People were asking about long-range transport within this mod. Also, some basic questions about power, actual creating of the power, and efficient usage of it. So here, clearly we have a pretty long damn wire, and in here we have 2 fully, these are the most electrically demanding doohickers right here. And they're running at full power. The voltage is fine, they're working as they should, and it's using 11 amps. Yeah, it's pretty crazy. And we're using a big ass wire to have this have this power here. And the big concept is these big wires versus the small ones. We're going to talk about that later. But really what this video is about is kind of basic, the most basic thermodynamics and power in general. This mod is based on physics of the real world, and using my knowledge of that, I'm able to actually create a system that is quite efficient. So here, clearly, this is the power station. New and improved, using different kind of cooling, much more efficient at higher power. And here you can see that I adapted it for a 50-volt system. And little demos here that I have here set up from previous failed attempts to record this video. But this isn't going to be a failed attempt. I really do hope this. So now here is a basic power station, and we have some lights here. We have one light which is low power, and then we have a bunch of other lights. We're using a basic 50-volt wire, and we have a turbine here. Now let's recreate the setup. Let's just take out some fuel here, and put it over here. Assuming that you already know how to set up some kind of system like this. Just basic, difference between 2 temperatures, and that's why the furnace, the bigger difference between the temperature of this and the temperature of the heatsink will yield more power with the turbine. Yeah, we can put it light. This is 200-volt, won't work. We need a wire. Very high voltage wire will work. And we're gonna put some fuel in this guy, and we're gonna accept fuel. This is probably the part that pretty much everybody knows about. Oh, this is going at 100%. We don't want that to go at 100%, but obviously light works. So most people would be running these things at 100%, and would just expect everything to work, which is totally wrong. Our temperature here is a little bit higher than what we really need it to be. A lot higher. There's a general guideline that this mod gives. In this case, the 50-volt turbine, really, you should never go over 250 degrees Celsius in an uncontrolled environment such as this one, where if you add a new load to the system, things will change. My power station there, things are safe. They're actually controlled properly to the amount of usage they have. And here I actually set it to a decent level. We want to keep this around 250 to 50 degrees Celsius. You really don't have to be too picky about that. Just a little bit touchy, maybe. But just set it around the spot. These power stations can run quite far out of their temperature limits, and that's sort of the concept I use for these power stations, where they will run quite a bit out of their limits, but they will yield a lot of power for like a small amount of from just one unit. And this is a little thing about how these will change from different usage. So here I have one light and we have 5 others here. You're running a bit hot, but this will work fine. And if you take out one of these wires, load will come down like crazy. Temperature is going up, and this is already quite high above the 250 degree mark that we wanted, and it's still going up. So you want to lower this down. 33% works fine. This is what I use for this one. Sort of kind of figured it out there. Yeah, 200, almost at 250. It's perfect. So at one light, but nobody's going to be running one light. So if we re-add our power, this is going to cool down. You can see, this might still run, but once you actually start using power for like base lighting, as in like for your mine shaft, or that's the first thing I used this mod for, to light my mine shaft in our multiplayer server. The more you know. So you have to increase the usage, and back then I had no idea how these turbines worked, but after applying some logic to the situation, I was able to figure something out. And, as long as your lights are on full brightness, you really don't have to worry about this thing, unless it's going like way too hot. So there's that. Now that's sort of that whole power station doohickey. It's really easy. Here is solar power station. I'm using a bunch of solar panels and batteries to achieve this. So capable of running this many lights, but I have it hooked up to my power station right now. If you want a video about the solar panels, I can give you that, no problem. So it's now the part of the video where I show you about long range transport and the whole concept behind such a thing. So the big thing is check out what stats this allometer will give me. The most important one is the 4th stat, which is the temperature. This is running 3.6 degrees Celsius over 20 degrees Celsius. Why do I say that? Because 20 degrees Celsius is ambient temperature. Nothing can get any cooler than that, not even in a snow biome. Everything is at least 20 degrees Celsius, so I like to just use the number above 20 degrees Celsius. And that really gives us a gauge on how much power these wires will lose. So this wire is running just 3 degrees over 20 degrees, and that really is no big deal. You won't have any power loss over that. But if we look at like these look at the voltage, it's 3.2 kilovolt. So that's 3,200 volts of power. That's quite a lot. If we look here, this is just the 80 volt wire or 800 volt wire. This is running at much a high temperature because the load on it is much lower. This is just one of all 4 quadrants of this power station. So, this wire is the combined productivity of this whole power station. This is just 1/4. You can see how it's much colder, even though the voltage is much lower. There must be some kind of system here that's using more power. Basic physics makes these wires, or like each power station here is supposed to have equal amount of usage, amperage draw, but this mod sort of kind of ignores that, does its own thing. So here we have this wire is a little bit hotter, 22. Yeah, this is the most used wire, using 1.34 amps, and we're at 22.7. you can see here that it's 1.07 kilowatts. If we look at the very high power wire, we're using 3.84 kilowatts. And if we were using that amount of power on just an 800 volt wire, yeah, things would be very inefficient because these wires would heat up so much. You really have to worry about this temperature when it comes to long range transport. So if we go back to our demo here, we have our really high voltage wire down here and just a 50 volt wire here, and not very powerful at all. Here's your demo, and right now I have it hooked up to both the wires actually, so if we just take off one of the wires, these will still run no problemo. Right, this thing here running at 2 degrees higher, and that's good. That is really good. You really don't want it to be like any more hotter than 10 degrees for long range transport. Here we're using a 200 volt wire because these will only accept 200 volt. There is no 800 volt heating element that we can use, so this is our only option, and it's heating up like crazy. This is a very hot wire, but the wire is only going a very short distance from here to up here. But here's a great demo. Down here the voltage is 197 volts, but the loss is so good, or so great, from the heat of this wire. It's insanely hot, that if we go up here to the end of the wire, it's only 190 volts. We lost 9 volts over such a short amount of distance. That is the concept of the whole system. These lights are these heatings will not work if the voltage is too low. The voltage is perfectly acceptable here, but if we try and use up some of the if we try and use stuff from the 50 volt wire, which lower the voltage, less efficient it is over distance. So this is the lowest voltage for this higher versus the higher voltage. So let's hook it up to the higher voltage here, and we're gonna look at what this guy does. So we're using 7 amps in this guy, quite a lot. And look at the voltage. This is supposed to be running at 50 volts. We're only running at 8. Absolutely abysmal. You can't run anything on this with this kind of usage. Yeah, not even close. And here, these lights, not a chance. Rated for 200 volts, and we're only running at 32.4 volts. So let's try, maybe this might work if we disconnect the furnaces. This might work. Okay, our voltage is rising. This will work. But clearly this is a low use situation. If you're trying to light up your mine shaft, then you're gonna have a lot more lights than just 2. So if I just continue this system with all the lights, even the 50 volt won't work. But that I'm already kind of showing that off with these furnaces because their usage is so high that they're just gonna soak up everything this wire has. And if we look at the temperature of this wire, we have about 6 degrees higher, and it's still rising like crazy. You know, use common sense when you're using this kind of long range stuff. Don't try and go the shortest the lower power wires for the longest distances like I'm trying to use here. We're 10 degrees over the amount, and clearly not a chance at running anything at this end of the station. Not a chance. So if we go back and connect our high voltage wire, everything will start working because of the efficiency of this. The voltage physically what's going on is there's less friction of the electrons in this wire because the higher voltage is so much higher. Power, you might not know this, but power always goes the same speed, but voltage is sort of that, is the difference between, like, it's the potential energy of electrons to jump to something else. That's what voltage is. Amperage is the amount of electrons, but the voltage is the potential of that electron jumping to another neighboring atom. So you can see here that there's going to be a lot more influence of these electrons traveling the wire with a lot higher of a voltage, because the push of the electrons is a lot higher. That's basically it. With a 50 volt wire, the push isn't that much. The voltage, it's like this is why highways exist. Here's an analogy. If everything worked off of residential streets, avenues, all that stuff, not highways, then things are going to be absolutely abysmal. People are going to be going at like slow rates. Nobody's going to be able to go anywhere. But with highways, we kind of fixed that with short range. This 3.2 kilovolt wire is like an airplane. Very fast, very efficient. And that's why we need to use these guys over long range instead of the 50 volt. So for your base lighting, I would actually recommend using just a 200 volt wire. If you have a really big base, use like a 800 volt wire and just have like substations. Well, what I mean by substations is that none of these appliances, like the lights or the furnaces out there, any kind of machine, will take advantage of 800 volts. It's just not possible in the mod right now, and I highly doubt it will be. But there is a way we can use this power, obviously, because I was able to take advantage of it. They're called transformers. If you look up what transformer is, they're basically wireless energy, except over a very short distance, and it transforms power, like very high voltage to low voltage or vice versa, and the wattage between point A and point B will be the same. The wattage is the amperage times the voltage, and so if you do the math, then if you drop down voltage, which is what we're doing here with the 3.2 kilovolt wire to the 800 and the 200, we have to do these steps because these transformers aren't have much capability as in doing big steps in power. They can only go down to like 1/4 of the original power, or amplify the power by, not exactly amplify, but transform the voltage to 4 times what it is. And the amperage will be affected by that, as in if you try and increase the voltage, the amperage will decrease. There's no free lunch. You're never going to get any extra power out of using transformers. So yes, that's how that works. And here's my failed demo. Let's make a new one. It would be great if I actually had a I already demonstrated with that system. And we're gonna use this transformer guy right here. I'm gonna hook it up right here. We can't hook it up because that's not actually the transformer. I'm gonna have a transformer here, and to the other side of our base, or wherever we need the power, we're gonna have another transformer. We make a little path here. Get not a very high voltage wire. We don't need this. It's best to use the appropriate wire for this. Clearly I was using very high voltage wires. With this mod, you can use a very high voltage wire with lower voltages, except it won't accept that many amps. So our 200, this will accept 10 amps, but our high voltage only accept 4.69 amps. So this is why it's best using the actual proper wire for the usage. So we're gonna not amplify, but increase the voltage of this by 4 times to yield 200 volts, approximately 200 volts. This is running a little bit higher. So if we use our optimal ferromagnetic core, there are multiple cores. If we search them up, we have 3. Sorry, we have a cheap, which if we hold shift, we're gonna lose 10 times the power. We're gonna use from point A to point B. We're gonna lose 10 times as much amperage from point A. Not exactly lose it, but you won't be able to push that much power through the transformer. And here, not a little bit more efficient here. This will not lose any power. It's the most efficient option. But we're going to be using the cheap ones because most people won't have the resources to get any of the higher ones, and using the cheap ones for base lighting, perfectly acceptable. Yeah, we have these guys connected. Now this is the really kind of scary part if you have a running system, because if you do something wrong, these things are going to explode. So here we have a green side, we have a yellow side. We have to take note of that. Here we have a green portion and a yellow portion, and we need to take a low voltage wire too, as well as the medium voltage wire. And what we need to do, we have to hook up the side with the power first. So if we take our things right here, which this is actually the wrong stuff, we have to actually use, this is the low voltage cable. We have to put the low voltage cable on the yellow side because the yellow is here, and the more windings there are on a transformer, the more voltage you're gonna get. So we have to amplify the voltage by 4 times. No, I'm sorry. The more windings you're gonna get, the less. The more windings. This is kind of confused right now, but the more windings on the low voltage side, yes, that's what you need. The more windings on the low voltage side will yield more voltage on the high voltage side. So if you put a cable right here, we check our voltage. Never mind, I'm wrong. I was doing the pay which one it was. So more windings, more voltage. A lot simpler to remember, not the inverse. But here we're getting our 200 volts, exactly what we need. Now, imagine this is actually a system like an 800 volt system. Can't really use that. So we need to have a step down transformer. That's what these are called. So we take our, oh shit. Yep. See, this is kind of these transformers without any kind of windings in it will have 1-to-1 power. So 200 volts here will go straight across to the 50 volt wire. This is why these are so fidgety, because you don't know. So if we put a core back, and so as I said, more windings, more voltage. So this is our wire with more voltage, 200 volts. We want to step that down to 50 volts. So we take our medium voltage, put it here, more windings, more voltage, and then we put our low voltage on the place where we want the more low voltage, just one winding. And here, 50 volts. We get exactly what we had there, and we can run as many lights as we want. And if this kind of system becomes an issue where you're still going to be losing a bit of power, because always check that kind of voltage of your wire and also the temperature too. Then you can just simply add a new transformer. We're going to be using our high voltage. Here we have our high voltage. So as I said, more voltage, or more windings, more voltage. So we take our high voltage, we put it, or we want to connect our yellow side first, because that's the place where we have power. I would actually strongly advise you to not have any power hooked up before setting these up, but we have one medium voltage and as I said, more windings, more voltage. So we want to 800 volts. So 200 times 4 will give us 800. So we put 4 wires here. Get more voltage on this side. If we test our results here, we get 800 volts like we want. If we disconnect our power there, reconnect it here. Oh my god. It's that same mistake I made before. The power just went straight through the transformer and blew up all our lower voltage stuff. Really, this is the part I really don't like about this mod. Things explode. Not because it's impossible for these things to explode. It's because they won't explode under these conditions. If you put higher voltage wire through a smaller gauge wire, which is what we're doing here, this is basically just a smaller wire, it won't explode. It'll actually, having a smaller gauge wire is better for low voltage or higher voltage applications, but apparently this mod doesn't understand that. And thicker wire is better for higher amperage applications, and the less voltage the more amperage you have to have equivalent wattage. So we don't want to hook up this thing yet. We take our high voltage, which we put 4 of these guys, put a core, and we want to take our medium voltage, put it there. Now we have 200 volts here, less windings, less voltage. Then we take another transformer here, green side. Sometimes, if we flip it around like this, everything will kind of work. Or if you set it up on this side, these sides will match. But if you go around to this side, then this is where the sides won't match. So it's better if you just set this up right there on the spot. So more windings here, core, and we're gonna have our low voltage. Now we have 50 volts. So what we did here is we went from 50 to 200 to 800 to 50 to 2 to 50. And if we check our voltage, it's 50. We get 50.48 volts in here. We lost a little bit of wattage because the wire's slightly hot here. Just 1 degree, you can see the voltage drop over this distance, not a big deal. But you can see if we just took this out, if we string this out as long as this wire right here, for like your average base lighting, this would not work. And this would work more than adequate. Now, for the end of the video, we have a new and improved power station design here. A new equation, new kind of workings. As I said before, this kind of runs outside of the mod's designated ranges for safe operation, but we're not safe people. We're playing a video game. We push things to the limit. So here, where you have a 200 volt power station and a 50 volt power station, we both have furnaces running. The 50 volt furnace faring a little bit better, simply because these don't take as much power as, say, the 200 volt furnace. And this is using up 100% power. This is only using 50%, 57%. We check our voltage here, pretty much exactly 50 volts, a little bit higher. I kind of made the curve a little bit aggressive so that you would have it would compensate for the voltage drop of this kind of wire distance, so that if you really actually went balls to the walls with this system, you would transform things immediately as soon as possible. So here we're transforming straight out of the power station and going straight over to our high voltage cables here. This is the kind of system you want. You want the higher efficiency wire for most of your system, for the most efficient systems. And so this is our new system. Instead of using thermal control like we were using before, we're going to be using just control out of what is coming out of the wire. So here, this is double the voltage of this wire, so 100 volts. So we want this result to be around 25 or 50%, which is what we have here. And here is 20 watts. We want this is the amount of usage of the wire. So if we test our wattage here, or amperage, it's about 10 watts. So this should be exactly 50%. So if we go here, the rule of thumb I discovered is that the furnaces should run at the percentage equivalent to the amperage with two combustion chambers inside. So here we tested about 50 watts, or 50 percent of like the maximum amperage the wire can take, which is 20 amps. So if we test this wire, or this one, 20 amps. So you know, this thing is 50 50% plus a little bit of change, which is required to actually have the system up and running. I'm using the voltage simply to make this system a little bit aggressive. So suppose, like, you know, a new load comes on the system, the voltage drops like a rock. We want this system to adjust right away. So that's why we're testing the voltage. So if this voltage just drop like a rock, we can actually adjust for this fluctuation very easily. And here in the equation, C is the voltage input. We're doing 0.5 minus C, so we want this to be about half. We want this to be at 50%, because that's what we set the wire for. So if this is at 50%, which is what we want, with 200 volts for this wire, this will yield about 0. And 0 times 32, there's no influence on this system. So suppose this voltage is dropped, this would go down to 0.25. So 0.5 minus 0.25 would give you 0.25. That times 32 would influence the system greatly to yield more power, because the voltage dropped. And if the voltage declines because we take off a load, then this would become a negative number. Or yes, this will become a negative. Yes, will become a negative number, because, you know, 0.75 minus 0, or 0.5 minus 0.75 as an example, will get negative 0.25. And that times 32 will influence the system, where it will decline the usage of these systems. So suppose we take off this. Our furnaces here are running at the lowest voltage, or the lowest wattage they can, which is 10%. And in a while here, when the system, you know, fluctuates, goes to the 50% mark, you know, the voltage will increase, or the usage will increase to do that. And this is quite aggressive. Adjusting this number higher will make the system more aggressive. 32 looked like a good number. The higher the better, actually. So here, you know, we saw it go up to 100, and quickly we went down to 58 because the system like quickly adjusted for that 15 volt usage. We take it off, then our voltage is going to be much higher. We're going to get that negative number, so the system is going to be influenced where it's going to be lower. And so once we drop down the voltage to what we think is acceptable, which is 50 volts, our system is going to go, it's going to be like, oh shit, I just destroyed it. You know, here, if there was no, I have no idea what just happened to the system. There was no, I guess there was no usage for any of these. So, you know, they were going crazy because these fans are also drawing a little bit of power. So we're dropping down the voltage, and And this guy, you know, the system's like, oh yeah, that's a nice voltage, and we're gonna go down, and here, you know, still going down just a teeny bit, and you know, we're gonna get about 50 volts exactly. Here, turn this guy on. Voltage goes up, compensates a little bit for that voltage loss over the distance. So here we should be getting about 50 volts, which we are, and this kind of applies for the 200 volt system. So here, exact same equations. I was surprised to see that we use exact same equations for this. And the only difference is the settings to these wires right here. So we're gonna make one of these guys like we did before. So let me make up a little platform here, destroy this demo here that I made for previous attempt of making this video. Failed. I like making the base of these out of stone bricks. And so we're just gonna set up our standard system that we had before. We had these things here. Turbines, wrong way. Red goes to the hot side, blue goes to the cold side. These guys, there are two sides to the active thermal dissipators. There's gonna be a big like circle here, and our small little thing. The small little thing is where the power goes in, and our big circle here is where the heat comes in. So we want to make sure that we get the small little thing here for the wire. So we take our wire, put it here also to connect the turbines. That's where we take our power. Here's a little rod to take out the power from the system. We could take it out also from here, you know, make it come up here and have this system there, but you have to do some kind of weird stuff, taking blocks across so that we can connect the this guy right here. So we take our electrical probes, and this will test for wattage, amperage, or voltage, any of the three, and we get a wrench to reorientate these blocks so that they face the right way. So the lower one is going to be your voltage, so we're going to put it here, there. This one goes to the right, this one goes to the left, and oh god, I'm going to go into these, and these wires are rated for 200 volts. No, 50 volts. I'm tired. Even though I'm in my PJs, it's the morning. So we're going to set this to 100. That's double the 50 of this wire rating. Validate that. Voltage. We want power is the wattage. Current is the amperage. And we're going to go over here. This is going to be amperage. These wires are rated for 10 amps, 20 amps. So I'm wrong. We put 20. Put the current, which is amperage. Validate. One thing we forgot, we have to put a wire in here. Bada boom, bada bing. We have that. Take a control box. Have this guy here. Should connect, right? Take our some fuel. So where's your cold blocks? Or did I? This is what we want. Did I misspell coal? I think I did, because I should have gotten that. We wanted combustion chambers, 2 of these. We don't need any regulators because we're doing that out of these a little bit better, I think, because, well, you can really fine-tune these kind of things a lot safer. Plus they work nicely with these these turbines here. Put in an equation, give it a bit of redstone. Did I see? No, 8. Thought I said 2. Redstone required. We put a redstone here. It's gonna be, oh, I'm happy now. And we have to. The last thing we have to do is set this to external output. So if we test this wire, it should be giving us. Oh, we set the output wrong. We have to take our wrench again, and we have to reorientate this black to be down. The black is the output, so down 2 clicks. Rotates it 180 degrees, or 1.5 radians. No, 3.1415 radians, and we have 50 volts here, maximum 100%. That's what we need. And internal, these guys are gonna go like crazy. But once we go down to that limit, gonna adjust right away, right there. We should be running at 200 volts here. 50 volts, I said. The 200 volt systems will be similar. Just use 200 volt components. Set this to 400, this to 10. And this is that system. And here I have it set up. The reason I'm using active cooling is to maintain a decent delta temperature between the heating and the cooling. So with the passive, I wasn't achieving that, and there was some kind of threshold that if I were to surpass that threshold, then things would start getting a lot more. Things would start being a lot less inefficient. So once I put in the active cooling, it would stay under this like magical threshold, and things were staying like decent under load, especially these 50 volts. The 200, if you really push them, you can still like surpass these thresholds with just these heat sinks alone, but these are capable of 2 kilowatts each. So 2.2 kilowatts each. So you'd be actually using quite a lot of power, and at that point you would want to actually have like 2 of these units, or even 3, if you're using that much power. So that's why I just sort of kind of took it off with just 1 of the heat sinks, plus to maintain this extremely small footprint for the amount of power it produces and the amount of safety it has, because these things will never explode. As I said before, these go outside of their limits, but you know, these limits are quite high for this mod. Here we're going a lot under our limit, so these turbines are supposed to run at 350 degrees Celsius. That's what it says it should be. Oh, 350 degree delta temperature, so that's what it should be between here and here. So, oh, that might be actually perfect. So here it's 237, and here it's 20. Okay, that actually will not add up to 350 degrees. So, I thought I learned something, but I didn't. And we're still getting our 200 volts. Perfect. And if we go to a system that's using a lot more power, maybe this one. Yeah, this one uses about the most power here. And so this one is going still under the 250 degrees Celsius range. Oh, but there is a power station here that will for sure go over that. So here we're trying to power this furnace. It's very hungry for power. Here we're 290 degrees Celsius. These are running at 100%. Still not the best. If we try and tone this down a little bit here, then these will increase to over 3. No, these will never go over, I guess. Well, okay. The more you know. So, that is the end of this video. If you have any questions, don't be afraid to ask anything in the comments. can answer. I'm not guaranteed how quickly I can answer them. Usually I'll get the notifications, look at it, a week later I'll actually reply. Sort of lazy. Have other things to do. School. Gave myself quite a big bite of an assignment in programming class. Quite lucky that my school actually has a programming class. Well, yeah. Making a 3D game sometimes can be time consuming. So that is the end of the video. I hope you enjoy. And, as I said before, ask any questions in the comments. Don't subscribe. Don't like. Dislike a lot. And that is my conclusion. I was using Shadowplay to record this. I thought it's awesome. The only problem I have with it is that it won't record Minecraft, so that's why I have it in windowed mode, and you can actually see the whole Minecraft doohickers at the top, the actual Windows thing.